Okay, hello and welcome back. If you're new to the channel for the first time, please could you leave a like or a subscribe. That'd be really helpful. In case you don't know what I do, this is a bunch of videos really tuned in to people who are revising for GCSE Mathematics High Tier. And this particular set of questions I'm doing here are Think and Do questions. This is a new playlist. So if you want to look at the other questions or other videos in this series, just click onto the playlist, which you'll see in the list above. This particular set of questions is on trigonometry, and so I'll try and go through with you as I go along how each question sort of breaks down. Most of these questions are calculator questions as well, so you might want to keep a calculator handy in case you want to run along at home. Right, this first particular question is about circles and equilateral triangles. So in itself, it doesn't really look like a trigonometry question except that it's got a triangle in it. But it is most definitely a trigonometry question because it involves working out the area of a triangle using half AB sine C, which is another alternative view of how you work out the area of a triangle other than half the base times the height. So let's read through the question and deal with it as we go. Now it says it's got a circle equilateral triangle. Equilateral triangles, in case you don't know, have all sides the same length and all angles the same. One side of the equilateral triangle is diameter, so we've got diameter here, and it's also saying the diameter of or circumference of the circle is 44. Now we know that circumference is pi times diameter, so straight away my response to that is to write down the circumference formula. We're going to work out the diameter of the triangle by doing the 44 circumference divided by the pi, so that gives you the diameter, of course. Because it's an equilateral triangle, this would be the 44 over pi, but this is also going to be 44 over pi, and this is going to be 44 over pi, and this fundamentally is also 60 degrees because it's an equilateral triangle. Now we know that the area of a triangle, as I mentioned earlier, is half AB sine C, so we just need to put in half of 44 pi times 44 over pi, and then times sine 60, and that will hopefully give us the problem or the solution that we need. Once you throw all the numbers into the calculator, you'll get that being 84.9. Critically, you need to put it to three significant figures, so 84.9, that's the answer to that. Question 2 I've done before elsewhere on this channel, but I'll show you again. I'm not sure if I did it quite this way, but I'll show you another version of it in case you haven't seen it before. This actually involves quite a lot of working and calculation, so it's worth 6 marks. This question's quite a lot of marks. It's talking about a cuboid with a volume. Surface area also is mentioned. It's only giving you one length, which I'm going to call the height here, which is 2. And I'm going to call the other two lengths x and y. So I'll call this length here y and this length here x. It's asking to find the length and diagonal of the cuboid. As with all 3D trigonometry questions, you will always work out the diagonal of the base first. So just sketching through the base, we have x and y. It would be useful to work out this diagonal here, which should be the square root of x squared plus y squared. Okay, so that would be from Pythagoras that we've got that, so we already know that's fundamental. Once you've got the diagonal of the base, we know that diagonal going from the edge to the edge, or corner to corner like this, will be this squared, so x squared plus y squared, and then plus this height plus 2 squared. Okay, so that will give us an square root, of course. So using Pythagoras, that is an easy calculation to strum up straight away, is to work out this diagonal here. So we need to work out where x and y are basically. How do we do that? Well, you'll use the values in the question. So first of all, it tells you about the volume. Volume is length times width times height, so 2xy in this case is 40, and also the surface area. Surface area will be all the different lengths, all the different areas of all the different sides added together. So there's this particular rectangle here, there's 2 of those, one at the front here, one at the back here. The area of each one is 2x, so there'll be 2 of those, 4x. This particular side here will have a height of 2 as well, so 2y, and there'll be 2 of those, so that's 4y. Then you will have the base is xy, and the top is xy, so you've got 2 xy's there, so that's all the 6 sides taken account of. And we're being told in the question that surface area is 100, so I'm writing in the 100 there. Now we're told that 2xy is involved and 2xy is 40, so I'm going to include that. So I've got 4x plus 4y equals 60 here, because we know that's 40, so 100 take away 40 will be 60. So we've got two formulas here, 4x plus 4y, and then this one, 2xy equals 40. Now from this, I have to eliminate a variable, so I will know that y equals 20 over x. You can see that really quickly if you do some substitution and some movement around. So I'm going to use the substitution in here. So 4x plus 80 over x, because 4 lots of 20, and then 60 here. That creates for us a quadratic, so 4x squared plus 80 equals 60x, which gives us a quadratic 4x squared minus 60x plus 80 equals to 0. I'm going to divide everything by 4 to make it a little bit easier for myself. It gives me a quadratic here, which again, looking at that, it looks like it's going to be unlikely I'm going to be able to solve that using factorization. So what you're going to do now is you're going to use the quadratic formula to work out what x is. X equals minus b, so 15, plus or minus the square root of b squared, so that's 225, minus 4ac, which is going to be 80 here, and all over 2. And then we've got to work out what 225 take away 80 is. That's going to be 145. And then what we're going to do is we're going to use the calculator here to throw these into the calculator and work out what each of these values are. Now they get quite long, these values, so you have to be careful how you write them down. So because we're going to need them in a minute, so I'm going to write down the whole long thing and show you what they give you. So this is one of the values that you get, so 13.520797929. So this is x values, of course, so 13.520797929 dot dot dot, or the one where 15 take away square root of 45, or 145, sorry, and that's this one, so 1.479 2711. Now the y values will be 20 over x, remember, so the corresponding y values, when you divide 20 by these values, you actually get similar values again. So y is 1.479202711, or again 13.52. So these kind of go together. That's because it doesn't matter which, earlier on, it didn't matter which one I called x and which one I called y. It doesn't really matter which way around you get them. The maths sorts itself out. So this is the x value, this is the y value. Now you have to pair them off, so I'm going to use this pair, 13.52 and 1.479, and I'm going to go back to my quadratic from my square root from earlier to work out the side length. So it's going to be the square root of x squared, so 13.5207979, square root of y squared, which is 1.4792, and then 2 squared. Add them all up, square root them. That hopefully will give me my answer. So I'm going to write that all up here. And then square root all that up. So I'm going to use my calculator to write those in. Use the long numbers on your calculator. That would be really helpful, because saves you any rounding error that you might get, which is very common in these sorts of questions. So just make sure you've taken account of all of those values and carefully worked your way through, and you will get the questions quite quickly through. Make sure that you always give your answer to 3 significant figures as well, so that's also quite important to do that. So just working my way through this, so bear with me a minute. So it's 189 is what you get when you square all those things up, and the square root of 189 is 13.7 to 3 significant figures. So I'm just going to write that in here. And then again, just a reminder, this was worth 6 marks, so 6 marks there to get it all through, and we're done. third question in this set here will be about trigonometry again. So tan, opposite over adjacent here we're thinking, because right angle triangles, opposite over adjacent. This particular one, tan E, is x over 4x minus 1. Tan F is 6x plus 5 and 12x plus 31. Now, by doing some cross multiplication, we're going to set up an expression here, an equation here. I'm going to multiply out these brackets. Multiply these out, so 24x squared minus 6x plus 20x minus 5, and oops, that's going to give us 24x squared, and minus 6 plus 20 is plus 14, and then we're going to try and gather together the things that are alike. 24x minus 12x squared is 12x squared. 14x minus 31x is going to be 17, I think. And then minus 5 we're going to have on the end. And again, this doesn't look too complex, because if you multiply the first number by this number, 12 times minus 5 is minus 60, and I can find factors of minus 60 that add up to make minus 17. It's minus 20 and 3. And so I'm going to write 12x squared minus 20x plus 3x. Sorry, I should have done that wrong way around. Take it back. 12x squared plus 3x minus 20x minus 5. In case you're wondering how I knew I did it the wrong way around, because 20 goes with 5, 3 doesn't go with 5, so I need to make sure they're listed in the right order. Factorise first pair, so 3x, 4x plus 1, and then take out the 5 as common, so you can hit 5, and then again 4x plus 1, and then again that gives you the pair of values 3x minus 5, and then 4x plus 1 equals to 0, which again shows you that x is 5 over 3 or minus a quarter, those two values. Now again, given that these are side lengths, because they are, we eliminate negative 1, so it's 5 over 3 was the answer we want. That's quite a lot of marks for quite a lot of work for 5 marks, but that gives you an indication about where they go. I picked up this question because it involves conversation about what makes a congruent triangle, and these sorts of questions come out a lot. I also picked this particular question out because it does require some good thinking. And if you don't think about it in this way, I don't think there's any other way of doing it other than this particular way. So I'll go through with you how to do it, and just want to talk you through it a little bit, make sure you've understood the logic about why I approached it in this particular way. So it talks about the quadrilateral, XBYA, that's this thing, XBYA. A, B and XY intersect at the point M. It's asking you, telling you the area of a triangle AXB, so this one here is the same as the area of this triangle here. And it says prove that XY is bisected by AB. So there's quite a lot of, it's just very minimal information, isn't it? It's not very much they're giving you. They are telling you about area though, and that's the key. So in this particular problem, we haven't got any angles given to us. So it seems to me that to get the area in this case, you would need half the base times the height. So I'm going to start by constructing the perpendicular height here for this triangle. It's at H, and this particular height here as G. And that's perpendicular, so I'm going to write a little 90 degrees in the corner. Now we know the area of this triangle is half the base times this one, and the area of this triangle is going to be half the base times this height, and we're told that they're both the same. Now, if the areas are both the same, the logic is that the particular heights have to be the same, because they must be, because they share a side. AB is shared by both, so if AB is shared by both, they do have to be the same perpendicular heights, because otherwise it wouldn't work, and the area is the same thing for both. So we have to write a little bit of explanation for that. So I'm going to say, since area triangle AXB is equal to area triangle AYB, this implies that GY is the same as XH. Must be the case. The heights must be the same. If you also look at the angles in the diagram, this angle here must be the same as this angle there because they're vertically opposite. So I'm going to say that. We'll say GMY, the angle, is equal to angle XMH because they're vertically opposite. And because they're both 90-degree triangles, YGM, angle YGM, is equal to angle MHX, because 90 degrees. Now, since these two triangles then have this side the same, this side the same, two angles the same, they have two angles and a not included side the same. So they have AAS, which implies that they're congruent triangles. So MGY, triangle MGY, is congruent to triangle MXH. Now, if they're congruent, basically that's the answer, because that's telling you everything. Because if they're congruent, it means that these two lengths, YM, must be the same as MX. They have to be, because they're congruent triangles. So MY equals MX, which means if these two lengths are the same, then they must have been bisected by that point. So that's your proof. It's a little bit of logic, a little bit of thinking, a little bit of calculation, but not much, just a little bit of conversation about what congruence means. Question 5, here's one here, talks about a triangular field with fertilizer, and it's talking about different measurements being measured to either nearest degree or nearest 5 meters. It's trying to catch you out on how nearest measurements work or bounds work. So just be cautious with bounds to make sure that you've got a good understanding about how bounds operate. So firstly, 50 degrees calculated as nearest degree. The upper bound for that will be 50.5, have to be. Also, the 225 correct to nearest 5 meters, the upper bound for that would be 227.5, and 175 meters to the nearest 5, the upper bound for that would be 177.5. So just be cautious about how you know upper bounds operate. Always the trick is to halve the bound, so 5 divided by 2 is 2.5, and is added on, so 2.5, 2.5. And this one, if you halve the bound again, that's 0.5 of a degree, so 50.5 of a degree. We're asked to work out the upper bound for the area of the fields, just like earlier. This is a half AB sine C problem. So we're going to do half of 227.5 times 177.5, and then sine 50.5. And then throw those into the calculator, which I'm about to do, and hopefully you'll have your answer, which should be easy to calculate. You can see at the bottom there, the question's only worth 3 marks, so it's not particularly difficult. And you will get this answer when you've thrown them all in, which I'm going to show you there. It's 15,579, so 15,580 roughly. I'll put that to 1, 2, 3, 4 SFs. And that's a rough calculation, and that will do. And I'm sure the range of questions or answers in the question will give you a big range to look at. Question 6. So question 6 finally is looking at area of a parallelogram. We know the area of a parallelogram is the base times the height, perpendicular height. So again, I'm going to draw in a perpendicular height here, similar to the question earlier. I'm just going to put a little h there to show the side being intercepted, and I want to work out what CH is. You can see I've created a right angle triangle, and because I've got the opposite here in the hypotenuse, sine 40 equals the opposite over the hypotenuse, so it means the HC is going to be 5 sine 40. And then we've got, and then then to work out the area of a parallelogram is going to be 7 times this. So area will be 7 times 5 sine 40. And so it's a straightforward, just throw those into the calculator and understand what they are. So I'm going to do that right here. So to show you doing that, 7 times 5 times sine 40, and popping them in, and you get 22.5. Just taking a little look to see whether it wanted you to round it to whatever. So it's one decimal place in this case. So 22.5 centimetre squared. And that is the end of this particular set of questions. I hope those are all clear for you. As I said earlier, if you're new to the channel, please do leave a like or a subscribe. That would really help me out a ton. And hopefully I will see you soon on some other videos, which we'll do in Think and Do. Think and Do is coming up in Shape and Space, and we've got a Think and Do on handling data coming up. So do tune back and have a look at the channel, and you'll see those appearing, hopefully, in the not too distant future. Goodbye for now, and hope you have a really great day.